All right, Geometry, Module 1, Lesson 9. The title of the lesson, Unknown Angle Proofs. And it's really the first lesson where we get into actually writing formal proofs, being able to make statements and then justify those statements with facts that we already know to be true, which we worked on in Lesson 6, 7, and 8. So today we're going to again, identify what our outcome is. Students, you will be able to write unknown angle proofs using already accepted geometry facts. Let's get started, as we've already done the warm-up problem, and let's get started with sort of that introduction to writing proofs, proving things, in other words. Okay, so during this video, we're going to briefly discuss some of the what amounts to be an introduction into what are we trying to accomplish with these facts that we know to be true. In geometry, we follow a similar deductive thought process. Okay, in this video, we're going to look at examples and discuss this idea of proving something through deductive reasoning. And so the first thing that we're going to look at, and they prescribe to us here in this first example, is the idea of the remote interior angles being equal to an exterior angle. This example right here. So we already know that we've been given this fact that 78 is equal to 42 plus A. We've already learned that the remote interior angles, 42 plus A, is equal to the exterior angle, 78. We learned that in previous lessons. So suppose that we take a generic approach and we label X and Y to be the remote interior angles and Z to be the exterior angles. And we want to prove that in every situation, this is going to be the case. And so what you have is provided for you with this statement and reason. And what I am going to offer for you is we are going to have an approach, and it's called a two-column approach to proving things. And given the fact that they've given us sort of a look at what the statements would be, and then the corresponding reasons. For example, statement number 1, the measure of X plus Y plus W. X plus Y plus W is equal to 180. And we know that that's true because the sum of the angles in a triangle is 180. So we know that to be true. So we can make that statement, and for the reason that's stated. Again, this is a two-column approach to proving that angle Z is equal to the sum of angle X and Y. In statement number 2, W plus Z is equal to 180. W plus Z is equal to 180, and the reason, linear pairs form supplementary angles. So we know that to be true. Statement 3. And this is where it sort of gets to be like a puzzle. You're trying to put together a strategy. X, Y, and W. X, Y, and W are equal to W and Z. And the reason is the substitution policy. Or rather, the reason is the substitution property. It hinges from up here. Since this right here is equal to 180, and this statement right here is equal to 180, we can set these two together. And so again, we're putting together a strategy. In this case, it's a two-column approach. List the statements, list your reasons, all in the hopes of proving X plus Y is equal to Z. And the final statement, and they give this little dot right here this means that this is what we are trying to prove. That's what we are trying to prove. X and Y is equal to Z. Now, how'd they get there? Well, they state the subtraction property. And the reason is because if you subtract W on both sides, they reduce out. And you're left with X plus Y is equal to Z. And so we've proven the remote interior angles of a triangle are equal to the exterior angle. Okay. Okay, so we just introduced writing formal proofs in a two-column method where we had the reasons and the statements given to us. And so now we're going to take another problem and we're going to actually work it out ourselves. So notice that each step of the previous proof, we were justifying the statement with things that we already knew to be true. And then we were building those up to the very last statement, which was what we were trying to prove. This is called deductive reasoning. It's kind of like Sherlock Holmes and the idea of he just kept putting facts upon facts and proving them based on what he knew to be true. And so we're going to do this here in number one. So let's start with number one here in one that we have to create on our own. First of all, you know that the angles on a line sum to 180. We know this. It wants us to prove that vertical angles are equal. So we're trying to prove vertical angles. So let's make a plan. What do you know about W and X? And then what also do you know about Y and X? Well, I know that W and X, we know they form a line, so they're supplementary. And then we also know that Y and X are the same thing. They form a line. And so that should help us. What conclusion can you draw based on both pieces of knowledge? Well, I know that by virtue of this relationship right here, I think I can form a proof that W is equal to Y. W must be equal to Y. So let's write this proof out. And let's continue with the idea of we're going to do a two-column proof. So first, I write my two columns. I'm going to put statements here and my reasons here. Statement number one. Well, statement number one is I'm just going to abbreviate angle W plus angle X is equal to 180. And the reason? I'm going to abbreviate supplementary angles equal 180. Number two, angle Y plus angle X is equal to 180. And again, the reason they're supplementary angles. The third, because both of these were equal to 180, my next statement is going to be angle W plus angle X is equal to angle Y plus angle X. And that's going to be substitution. I'm just substituting it out. And then finally, I notice that I have these two on either side of the equal sign. So if I were to think of subtraction, think of this like subtraction. That reduces out, and I'm left with my final statement. Angle W is equal to angle Y. And the reason? The subtraction property. Subtraction. And so we've proven vertical angles are equal. Let's do one more. So we're going to do one more, and we're going to take number 2 and just do the first part. I'm going to leave the second part and number 3 for us to do in class. Number 2, given the diagram to the right, prove that angle W, X, and Z. Prove that angle W, X, and Z equal 180. So that's what we're trying to prove. So let's make a plan here, and we're going to do a 2-column proof again. And I'm going to have my statements here and my reasons here. My first thing is I'm going to write a statement that says angle X plus angle Y plus angle Z is equal to 180. And the reason is because the sum of the interior angles in a triangle equal 180. So that's statement number 1. I know that X plus Y plus Z equals 180. Statement number 2. I know that angle W and angle Y are equal. Angle W is equal to angle Y, and the reason, because vertical angles are equal. Vertical angles are equal. So now my next statement is, I am able to simply say, because of these two, I can substitute in for what we're trying to prove is W, X, and Z. W, X, and Z. I can substitute in for the Y now that I have W equal to Y. And so my next statement is what we're trying to prove. Angle X plus angle W plus angle Z is equal to 180. And the reason? Substitution. And I've proven that angle W plus angle X plus angle Z is equal to 180. It's a 3-statement proof with the reasons off to the right. And this is going to conclude our initial introduction into proofs. All right, talk to you soon.